the narwhals in the sauna.
Yeah, hi everybody. So thank you, Fernando. I'm Philippine. I'm a postdoc researcher, currently based at the University of California, Santa Cruz, so quite far from here, but I made the trip. But I'm working for the Greenland Institute from there on narwhals, but also on belugas and bowheads. So today I'm going to focus on narwhals and climate change and how climate change, so far we've learned how it, like the different impact that can have in climate change on both the demography and the behavior of the narwhals. So due to increasing sea temperature and melting sea ice due to climate change, this has a profound effect on low trophic level organisms like phytoplankton, altering their abundance, diversity, but also their distribution, so where actually the prey are. Which in turn will have cascading effects on the entire marine food chain, from plankton to apex predators, such as bowhead whales, narwhals, belugas, and all marine mammals. So these will have strong impact both on their behavior in terms of habitat, but also in terms of maybe they will shift prey because the prey will just disappear in the area they are currently foraging, or they will change their diving behavior, maybe dive deeper to access deeper prey because the temperature at the surface is going to rise probably. But it could also have strong effect on the demography and population dynamics of this population, altering their abundance, the density, but also their reproductive success. So I first look into this. So to investigate that, we use the aerial surveys Heike was talking about to relate actually the whales' abundance to the sea surface temperature trends we could obtain from ocean models, from satellites, and this kind of marine models, to actually relate these two variables to see if the narwhals are actually affected directly by the rise in sea temperature. So here, this is the different submarine grounds that have been, where the aerial surveys have been conducted so far. So I just merged them into 6 different categories just to make it simpler. And then I looked at what is the sea surface temperature trend over time. So here you have 1993 until 2019. And you can see that here in what is called the CAA, this is the Canadian Arctic Archipelago, the sea surface temperature is pretty stable, steady over time. While when you look at the north sector and the northeast sector, you can see that there is this little slope, so a slight increase over time. But the most, let's say, the most spectacular increase happens in the northwest Greenland, so here, but also mid-east and southeast. And actually in mid-east, you can see that there is this very steep slope over time, so there is approximately 5-degree increase between these two periods, which is like a lot for this cold adapted species. So there is indeed these differences across sectors, both sides of Greenland. So then we wanted to investigate how could be the impact of these different trends in terms of temperature on the population dynamics of the whales. So then we simply looked at the relationship between the abundance of the whales here and the sea surface temperature. And you can see that there is this strong negative relationship, meaning that in the blue dots here, the Canadian Arctic Archipelago, there are much larger populations, while in the east sector, like here in southeast and mid-east, in this area, you can find the much smaller population, which is probably related partly to the strong temperature increase over time and this very, for us it's not that very, but much higher temperature for these animals. So in conclusion, we found that in the largest, like in the colder areas, West Greenland specifically here, like we found much larger populations, while in the colder areas here we have much smaller populations. So then we wanted to look at what could be the impact of this rise in temperature on the distribution and on the movement of the whales. So to do that, we used a large tracking data set extending from, I think it was 1993 until now, covering nearly 28 years and including 181 narwhals. So here we looked at 2 seasons, so in summer, so this is all each dot refers to one particular tracking position of one individual. So you can see, as Heike showed right before that, the whales are more closer to shore within the fjords in summer, while they go further offshore here and even here outside the fjord in winter. And then we used this data to train some models to relate actually the whale's presence to their environment. So we used mainly 3 different variables, and especially the sea surface temperature we were very we wanted to have some information about. And then we predicted what is the current distribution of the whale, and then to project what could be their future prediction, like the future distribution if the temperature continues to rise. So here this map shows the situation in summer. So this is like the current situation right now, and then I will show you the predictions in 2060 and then at the end of the century. So the color scale is simply an indication of the habitat suitability of the whales, ranging from 0 to 1. So 0 means low probability to find a whale, while 1 means you have like high probability to find one. So basically at the moment, on the data we trained the model on, the whales are located in summer within the fjord, which is not a surprise. But then which is more interesting, is that when you look at the projections in 2060, you can see that they are progressively abandoning these habitats here. And they are starting progressively to migrate further north here, because the temperature over here are getting too high, too high, too hot, too hot for them. And what about the situation in winter? This is quite different here. So the current situation, as just what I said, the whales are mainly located within the fjords in deeper waters, and here outside, mostly outside Scoresby Sound. But in 2016, the same thing, they start to migrate further north, but here the habitat is kind of expanding because new habitats become available because of the melting sea ice. But then at the end of the century, you can see that here is Greenland, the habitat is disappearing because it's getting really too hot in this specific area. So actually what we found is quite interesting. We have like kind of short-term extension of the habitat, but while there is kind of a long-term contraction with the narwhals abandoning some habitat where they are currently really like to. So, and there is this more dramatic scenario in the east, especially in winter, where the habitat, like our model predicted a complete loss of the habitat. So here, this is another way to look at these results. So basically on this map you have just the difference between the current situation and the projection by the end of the century. So it means that the red parts refer to the habitat loss between now and 2100. In blue, the gain, habitat gain, and in orange, when there is no change between both periods. And then we calculated what is actually the habitat change between these 2 periods, expressed in percentage between west and east. And here you can see that there is like not that much habitat loss for the West Greenland, while for East Greenland there is up to 20% habitat loss predicted. And then we also looked at what could be like the northern shift, so how far north they should go to avoid the warming waters. And here again, we saw like in the west, all these blue parts here mean that they're going to move probably further north to just avoid the incoming warming waters over there in Baffin Bay. And then the situation in winter is kind of different. Here you can see that this is quite impressive. Actually, I was surprised myself. All these red parts on the east sides mean that our modern project like a complete loss of habitat for this population in the east. And again, this northern shift for the population on the west side, which are gonna get some new habitats here, but migrating up to 160 kilometers north probably. But still, we don't know what will happen for this population in the east, because if the habitat is going to disappear, then we don't know if they're going to move or stay here, or hopefully they're going to move and not stay there and stay there. So, just a few key messages to take home with you, hopefully. I just showed you that we expect a drastic loss of habitat if temperature continue to rise this way. But it was also associated with this strong northern migration of the narwhals, probably to avoid the warming waters. We also showed, in terms of demographic consequences, that a smaller population are located in the east side, where the temperatures are much higher already at the moment, and they're going to rise pretty fast. We also showed some contrasting patterns between east and northeast Greenland, where east-northeast versus the rest, West Greenland and particularly the Canadian Arctic archipelago, where for these two, the waters are warming very fast, which have dramatic consequences of the narwhals, and we showed that they really depend on these cold waters to thrive. So this is all collaborative work. Of course, I'd like to thank everybody involved so far in the fieldwork analysis of the data. And thank you for listening. Hope you have questions.